All right, so let's check this out. This is actually yesterday's assignment. Yesterday we learned, like, with the fundamental theorem of similarity, if I dilate one side, I dilate all both sides, and they're gonna, this dilated A, right, is gonna end up on this line. So I'm going to show you, though, kind of a quicker, easier way to dilate on the coordinate plane. Like, we knew that when we dilated this A, we just used this X coordinate and we said, okay, 3 times 4 is 12, and it's going to be on this line, which is great. But what if we don't want to draw the line? Or what if we don't even have a graph? Can we figure out these coordinates? So, and the answer is yes, we can. And I'm going to just do random coordinates right there. So we're going to still say that R equals 4, except I'm going to do, I just realized it's not going to work on this screen. So we're going to do still R equals 4, but we're going to do this point right here. Okay. So R equals 4. And I'm not going to draw a line this time. I don't feel like it. I'm just going to look at the coordinates. Well, check that. I am going to draw a line because I want to show you guys something. So let's start by drawing a line, but we're going to ultimately get to the point that we don't have a line anymore because lines are kind of a pain. So there's my line, right? And R equals 4, because it says right there. So I'm going to take this X and I'm going to go, okay, it's 4, 1, 2, 3, 4. And then it's just on the line right there, and boom, and I need a bigger dot, and boom, there it is. But let's look at these coordinates, okay? Let's look at the coordinates that we ended up with. We ended up with a point 4, 8. Okay, so R equals 4, and we started with the point 1, 2. So 1 times 4 is 4. And if we look at our y coordinate, 2 times 4 is 8. So, like, I could take a point. This is where this becomes handy. Let's say I want to do this point right here, the point 13, 10, right? So here's my point 13, 10, and R equals 4. Where would that dilated point be? And see, the problem is it's going to be like on my wall over there. Like, it's not even going to, it won't even fit. There's no way I can do this. So, and I don't want to see where the point is. I just want the coordinates of the point. So can I give you the coordinates of the point? Well, yeah, I don't have to draw a line. I don't have to do anything except, I do need to remember that, let's name this point, I don't know, D. D for Debbie. O D prime equals R times O D. So if that X coordinate is 13, then that equals 4 times 13. And 4 times 13 is 52. I did that because I know that 13 times 2 is 26, and 26 times 2 is 52. So I have 52. So 52 is completely not even going to be on this graph. It's not going to be on my screen. Like, it's going to be so far gone. But I could tell you what the coordinates are because I can multiply 13 times 2. And if I can't multiply 13 times 2, I can pull out a calculator and have a calculator do it. And then the next one's significantly easier multiplication. 10 times 4 is 40. So it's going to be 0.52, 40, which is way easier than drawing a line, clear out to kingdom come, and doing all of that. Here's a question for you. Can I do shapes? Oh, yeah, I totally can. Let's erase this. And I'm going to draw a shape. And you're going to see how it's going to work with shapes. It's totally cool. Because, let's see. Let's make a triangle. So I'm going to make a triangle. I'm trying to make it, oh, hey, it's an upside down triangle. I'm going to try to make it actually so the coordinates are kind of smack on, just for easiness of life. Can we do this with fractions? Yes. The problem is telling what the fractions are. So I'm going to say if it's close, then it's smack on. So we have this round orange triangle right there. Well, can I tell you what the dilated points are going to be? And the answer is yes. So let's name our triangle. We're going to name our triangle, I don't know, cat, dog. Can't name it Bob. Can't have two B's. We'll just name it ABC, but we'll do it in orange. Not actually a Boise State fan. Some of you probably are, and go you. I'm not. So maybe I'll do a black and red triangle next. Okay, so here's ABC, and we need to figure out where A prime, B prime, and C prime are. So the first thing I need to do is figure out the coordinates of A. So the coordinates of A are 2, 8. So 8, let's figure out what A prime is. Well, R is still 4. That hasn't changed. Okay. So I have 2 times 4 is 8. And I have 8 times 4 is 32, which under no circumstances would that fit on my little graph here that only goes up to what? 14? No, 12 there, 14 there. So, so it wouldn't fit on my graph, but I can sure tell you what those coordinates are. I don't have to be able to see them. What about B? What are the coordinates of B? Coordinates of B are 4, 11, which is awesome. And then B prime is 4 times 4, which is 16, completely off my graph. And then 44. 11 times 4 is 44. So far off my graph. First of all, this triangle, I mean, R is 4. It's already up there. It's going to be a million miles away. Like maybe not a million, but super close. And then the triangle is always going to be big because R equals 4. So why wouldn't I do them on the board? R is never that big because it goes off the board. But now it doesn't matter because I'm just naming. I'm naming the coordinates instead of drawing the coordinates. And in a second, we'll do one with fractions, and you'll see how that one works too when R is less than 4. So C is at 6, 8. So 6 times 4 is 24, and 8 times 4 is 32. And we're done. And those are my coordinates. All right. So really awesome. Now, what if in blue here, we're actually, yeah, in blue, we're going to have R equal 1/2. Can we do that? We can do that. We're going to have R equal 1/2. Well, A is still, these coordinates didn't change. I don't have to go through and figure out those coordinates, but now I have a new R, so I'm going to have a new A prime. We're going to do it down here because there's just not room to go in that one. Well, I could move R. Just whoop, check me out. And then we'll move this. And then they can be on. Oh, all right, so A prime when R equals 1/2. So I'm going to look at A. Well, 2 times 1/2 is the same as 2 divided by 2. So A prime is going to be 1, comma, let's see, 8 times 1/2 is 4. I can graph these ones because they're going to be close enough that I can graph them. So there is my, oh, I need to make this bigger. That right there is my A prime. When R equals 1/2. We did it when R equals 4 and my A prime was so big and so far away, we can't even graph it. We can totally graph it when R is smaller, so we're going to. So B prime, but we're not, notice I'm not cracking out a ruler. I don't even know how that would work on the computer. I'm not measuring, I'm not doing any of that stuff. I'm just multiplying, which is great. And if I can't multiply, I can use a calculator. Calculator can help me multiply. Happy all over the place. So B is 4, 11. So 4 times 1/2 is 2, and 11 times 1/2 is 5.5. It's an odd number. I'm going to say 5.5. So B prime, I'm going to have to kind of eyeball it a little bit, but I can do that. So we have 2, and then we have 5. That right there is precisely 5.5. Why not, right? Sure. So there's B prime. If you have a fraction one and you can't get it perfect, am I going to care that much? Nope. All right, so C prime, let's see where C prime is. So C was 6, so C prime is 6 times 1/2, which is 3. And then we have Y is 8 times 1/2, which is 4. So we have the point 3, 4. And that right there is C prime. And then I just like, okay, so you are going to have to like use a ruler to connect the dots. That's not a big deal. We can connect dots. That's a lot faster than measuring, especially when it's like, is it 23.5 millimeters or is it 23 millimeters? And look, I mean, this guy's half as big as his friend over there, and it's twice as close because it gets closer to the origin when we dilate. And the R is less than 1. So that's really it. So if you're, when you're dilating the shapes, you can practice a little bit, or you can use a ruler if you really want to, but you don't have to. It's really easier to just map it out. Let's go over here. I have, I'm going to practice just if I give you random coordinates. I just happen to have a piece of paper here with coordinate plane on it. We're not going to use the coordinate plane though. So let's say I have coordinates 4, I don't know, 8. And R equals 1/4. Okay. So this is point A. So A prime, I just multiply everything by 1/4. So 4 times 1/4 is 1. And 8 times 1/4 is 2. And that's really all you do. Let's do an R that's bigger than 1. So let's say that I have point B. Oh, can we do negatives? Let's do a negative. Why not? -6, 5. And we will have R equal, R equals 9. Never would I ever do that one on the board because it would be like out of the building. But we can do this because I'm not actually finding the coordinates. So just multiply them. B prime is going to be clear down. Okay, so -6 times 9 is -54. So it's going to stay negative if it's negative. It's going to stay positive if it's positive. 5 times 9 is 45. So it's -54, -45. So it is going to be clear, like clear out, like up there somewhere. Okay. So that's it. We do another one with negatives. Let's do C. So we're going to have -2, -5, and my R equals 7. Why not? So C prime is, oops, that's supposed to be B prime. So C prime is, let's see, -2 times 7 is -14. And -5 times 7 is -35. And that's it. So don't overthink it too hard. It's not a super long assignment. And that's it. Good luck. And let me know if you have any questions. Bye.